You are listening to The Vocal Technologist. Spoken tech for your ears.
If you ask a Fortune 500 executive today what their, most expensive, least useful software license is, they probably won't name an AI tool.
Oh, definitely not.
Right. They will name Tableau. So today we're looking at this massive hidden infrastructure earthquake. We're getting into why the smartest engineers are realizing that writing the code is actually, well, the easiest part of the AI revolution.
Yeah, we are seeing a complete recalibration right now. The industry is sort of moving out of that honeymoon phase of artificial intelligence, and they're crashing headfirst into the brutal reality of system architecture.
Which is exactly what we are getting into today. We are sifting through two massive curations of technical data engineering, analytics, and AI newsletters from TLDR data.
There's a lot in there.
So much. And we've extracted the most critical insights just for you. If you are someone who wants those aha moments of tech without drowning in information overload, you are sitting in the right room.
Because the companies surviving this transition aren't the ones writing the cleverest prompts. They're the ones radically rethinking their entire data foundation.
Our mission today is to figure out how massive infrastructure scaling is colliding with this new AI reality. So let's start right at the code level. I keep seeing this phrase from Wes McKinney, who is obviously a giant in the data world.
Oh, yeah, absolutely.
He aggressively warns developers to stop doing something he calls vibe coding. What exactly is vibe coding?
So vibe coding is this incredibly common practice right now of blindly firing off a one-shot prompt to an AI model. You watch it spit out a block of code, and you just ship it into production because, well, it looks like it works.
Wow.
Yeah, you skip the rigorous code review, you skip the testing, you just, trust the vibe of the output.
Okay, let's unpack this. The old analogy I used to hear was that vibe coding is like letting a teenager drive a sports car blindfolded.
I've heard that one.
But I don't think that actually captures the mechanism of what's happening. It feels more like walking into a restaurant and letting a highly automated food processor cook the entire meal while the chef takes a nap.
That is a much better way to look at it. Because McKinney is advocating for something else entirely, which is called agentic engineering.
So if we stick with the kitchen idea, what does agentic engineering actually look like?
If we use your kitchen scenario, agentic engineering means the AI is the sous chef. It's doing the rapid, tedious prep work, chopping the onions, measuring the flour at lightning speed.
Right, doing the grunt work.
Exactly. But the human is still the head chef. The head chef controls the recipe, checks the temperature, tastes for quality, and ultimately, they decide what goes on the plate.
Which means they need the right tools for oversight.
Right. Developers are now using tools like superpowers and RoboRev specifically to keep their AI agents accountable. What's fascinating here is that the human's most important job in this workflow is actually deciding what not to build.
I read a memo from Anthropic in our source stack that really drove this home. You would think the company behind the Claude model would be bragging about how their AI can just write perfect SQL queries for enterprise databases.
You'd assume so, yeah.
But they actually said the opposite. They claimed that SQL generation is not the bottleneck for self-service analytics. If getting the code written isn't the hard part, what is?
The bottleneck is a massive governance and context problem.
Okay, how so?
Well, if you simply unleash an underlying language model on a raw, unorganized corporate database, it is going to hallucinate. It will pull stale data, or it'll completely misunderstand how a specific company calculates revenue, for example.
Ah, because revenue means different things to different departments.
Exactly. Anthropic realized that to make AI analytics work, you need canonical verified data sets. You need semantic layer-first workflows where the business logic is predefined.
So the biggest gains they are seeing come from, what, offline evaluations and continuous correction loops?
Spot on. It's not just about better SQL syntax.
That makes perfect sense of the data we have from Hex. They are running these things called Fable Evils, and they found that Claude Fable 5 is scoring like 10 to 15% better than other frontier models at complex, long-horizon tasks.
Which is huge.
It really is. But it is not because it types faster. It is because it excels at tasks requiring deep judgment, like taking a semantic model and meticulously cross-checking it against raw data.
And when you combine that human-led governance with these new agentic capabilities, the real-world business payoffs are just staggering.
Do you have an example of that?
Yeah, look at Capital One. They recently detailed a pattern they called data agents. They needed to analyze cloud dormancy.
Wait, what's cloud dormancy?
It's basically finding out which servers and databases are sitting idle and just wasting money.
Oh, got it.
So they were looking across 350 different resource types on AWS, Azure, and Google Cloud. Historically, performing that kind of cross-platform analysis took them 6 to 9 months of manual engineering.
I saw the final metric on that. They cut it down from 9 months to 10 days.
10 days.
How is that physically possible without just vibe coding and hoping the AI didn't delete production servers?
By building a highly structured, multi-step workflow, they used AI to generate the initial Spark SQL queries to comb through the asset data.
But they didn't just run them blindly.
No, they wrapped it in confidence scoring and automated false positive checks. Crucially, they mandated human validation at the end of the pipeline.
So the AI did the heavy lifting of mapping those 350 resource types.
Right, but the human remained the final arbiter of truth.
And we are even seeing this scale down to the individual level. The sources mention a new plugin combining DuckDB and MotherDuck that lets you run SQL blocks right inside Obsidian note-taking software.
Oh, wow. So right on your local machine.
Yeah. You can literally have a personal AI agent querying your local text files and freezing the results into markdown tables on your laptop.
That's incredible.
It is, but this brings up a massive issue. If we have AI agents making aggressive decisions everywhere, from Capital One's global cloud infrastructure down to my personal desktop notes, they require absolute precision.
Because if the data they are reading is wrong, the speed just makes the disaster happen faster.
Exactly. Doesn't this mean our old concept of a static, unchangeable database is essentially obsolete?
It does. It forces a total redefinition of what truth is in a data system. Amazon recently published a piece with a really profound realization. They said, ground truth is a process, not a static data set.
That's a big shift. For the last 40 years, we thought of ground truth as a historical snapshot.
Right. A human labels a piece of data, puts it in a database, and that becomes the golden record forever.
But Amazon found that for complex AI report fact-checking, those static labels fail. So they implemented what they call an audit then score protocol.
Which is fascinating. The AI is actually allowed to challenge the benchmark labels using evidence.
Wait, really? The AI pushes back?
Yes. If the AI disagrees with the existing ground truth, a human auditor reviews the dispute. By turning truth into a living, ongoing dialogue between models and auditors, Amazon lifted their expert accuracy to 90.9%.
But hold on, I need to push back here. So what does this all mean for you, the listener? Managing everyday data. Does this mean our old static spreadsheets and databases are basically obsolete if they don't have a constant built-in feedback loop? How does the AI even know how to argue with a human fact-checker? It doesn't inherently understand business rules.
That's the perfect question. And this is where we hit a critical distinction that companies frequently mess up. Taxonomies versus ontologies.
Okay.
The AI only knows how to argue if you give it an ontology.
I am going to stop you right there. I know what a taxonomy is. It's a folder system. It's tags.
Yep, pretty much.
It organizes concepts so humans can search for them, or so a basic vector database can retrieve related text. But what on earth is an ontology?
Think of an ontology as the physics engine of your data.
The physics engine?
Yeah. While a taxonomy just groups similar words together, an ontology defines strict mathematical classes, properties, constraints, and the literal rules of how concepts interact.
Give me an example of that.
Sure. A taxonomy says a manager and an employee are both staff.
Simple enough.
But an ontology says if person A is the manager of person B cannot approve person A's expense report.
Ah, I see. It has logic built in.
Exactly. AI reasoning requires those strict axioms. You have to keep taxonomies and ontologies linked, but separate. Business users curate the taxonomy folders, but the data models stay logically precise in the ontology so the AI can actually reason.
Okay, but even if you give the AI the perfect physics engine, how do we know it isn't just confidently lying?
That is the hallucination problem.
Right. The newsletters dove deep into the technical challenge of LLM calibration. They threw out terms like Platt scaling and isotonic regression.
Let's slow down for a second. What is calibration and why do engineers care about these specific methods?
Calibration is the science of making sure an AI's stated confidence level actually matches its real-world accuracy.
So if it says it's sure, it actually should be sure.
Right. If an AI says, I'm 100% sure this is the right code, but it's only right 50% of the time, that model is uncalibrated and very dangerous.
So how do they fix it? The simplest fix engineers use is called temperature scaling, which basically just softens the AI's overall confidence globally.
But that sounds like a really blunt instrument.
It is. It's too simple for a lot of tasks. So they moved to Platt scaling, which uses a mathematical curve to adjust probabilities.
Okay.
It is fast and doesn't require a ton of data, but it can still be too coarse for complex tasks. That brings us to isotonic regression.
Which sounds intense.
It's the most flexible method because it doesn't force the data into a smooth curve. It maps the probabilities step by step.
Is there a catch?
There is a massive catch. If you use isotonic regression on a small data set, it overfits. It basically memorizes the test rather than learning the actual underlying confidence.
Oh, like a student just memorizing the answers for a quiz.
Exactly. To track whether any of this is working, engineers monitor metrics like expected calibration error, or ECE, and Breyer scores.
So ECA is basically a scorecard grading how often the AI's confidence matched reality. If it was 80% confident, was it actually right 80% of the time?
Precisely. It's about teaching the AI to accurately doubt itself.
Okay, so if truth is no longer a static golden record, but this living, breathing dialogue where AI and humans are constantly overwriting data based on complex ontologies, how on earth does the physical plumbing of our databases keep up without melting down?
It barely does.
Hmm.
The underlying infrastructure is experiencing an earthquake just to keep pace.
Because the old way doesn't work anymore.
Right. The traditional method of managing data was called ETL extract transform load. You physically copied data from all over the company and moved it into one central warehouse so it could be analyzed.
And here's where it gets really interesting. I was looking at Salesforce in the newsletters. They recently scaled something called zero copy from 1 trillion rows of data to 120 trillion rows.
That scale's just hard to comprehend.
That is. They are doing this using a technology called Iceberg File Federation to support AI workloads, 120 trillion rows, without physically copying the data into a central lake.
Right, they leave it where it is.
My analogy for this is like having a magical library card. Instead of renting trucks to physically move every book from every library on Earth into one mega building so you can read them, this card lets you search and instantly read any book while it stays exactly where it was originally printed.
That analogy perfectly captures the mechanism.
Yep.
Moving 120 trillion rows creates massive network latency and governance nightmares.
It would be impossible.
Yeah. Zero-copy architectures let the AI query the data wherever it naturally lives. It reduces the compute overhead and preserves strict access controls because the data never leaves its secure home.
And it is not just where the data lives, it is how we are physically storing it. Vector databases, which power AI memory, are evolving incredibly fast. I saw Zillis introduced a new storage engine called Loon. Why did they need to build a whole new engine?
Because vector datasets are not static. A vector database usually holds two things: the vector embeddings, which are the complex arrays of numbers the AI reads, and the scalar data, which are the normal text and IDs that humans read.
Okay, numbers for the AI, text for humans.
Right. In older systems, if you updated a text label, you had to rewrite the massive vector array attached to it.
That sounds horribly inefficient.
It is. The Loon engine uses hybrid file formats so that the scalar data and the vector data are separated. They can update entirely independently, saving a massive amount of unnecessary rewriting during continuous backfills.
I also noticed Elasticsearch is hitting wild speeds. The sources say they are relying on an algorithm called HNSW to hit 15,000 queries per second with near-perfect recall.
Yes.
But they explicitly noted that exact vector search completely fails at this scale.
Wait, what is HNSW and why can't we just do an exact search? We have supercomputers.
Because of a concept called high dimensionality.
Okay.
Searching vectors is not like searching a spreadsheet. It is like trying to calculate the exact distance between every single star in the galaxy simultaneously.
Which takes forever.
It takes too long no matter how much compute you throw at it. HNSW stands for Hierarchical Navigable Small World. Think of it like building a cosmic highway system.
I like that. Instead of checking every star, HNSW drops you onto an interstellar interstate. It quickly routes you to the general neighborhood of the star you want, then lets you take local roads to find the closest match.
So it's an estimate.
It is an approximate search, yeah, but is the only way to process 15,000 complex queries a second.
That makes so much more sense. But it's not just the new vector tech evolving. The foundational, traditional relational databases are also adapting.
Oh, absolutely.
PostgreSQL 19 Beta 1 just dropped, bringing auto-scaling asynchronous I/O. But the thing that caught my eye was an update to PostgreSQL Anonymizer 3.1.
The privacy update.
Yeah, it introduces local differential privacy via GRM, controlled by a metric called epsilon. Hold up. Explain epsilon to me like I'm a developer who hasn't touched a statistics textbook in a decade.
Will do. When you feed massive amounts of user data into an AI model, you risk the AI accidentally memorizing and leaking personal information.
Like a user's credit card or medical condition.
Exactly. Differential privacy prevents this by injecting mathematical noise directly into the dataset. Epsilon is the dial that controls the volume of that noise.
So a high epsilon means what?
A high epsilon means very little noise. The data is highly accurate, but privacy is weaker.
Okay, and a low epsilon.
A low epsilon turns up the noise, obscuring individual records, but preserving the broader statistical patterns. It guarantees that the AI can learn that, say, 40% of people bought a product without ever being able to identify that you specifically bought it.
That's super clever. And just moving all this data over the network is getting an upgrade too. The newsletters highlighted Apache Aeroflight moving large columnar datasets using gRPC with zero copy transfer.
Yes, and a company called Streamling offering an open-source Rust runtime.
Right. Why do we suddenly need Rust and Arrow to move data around?
Because traditional network protocols serialize and deserialize data. They translate it into a network format, send it, and translate it back on the other side.
That sounds like it wastes time.
That translation costs CPU cycles and a lot of time. Aeroflight combined with Rust allows two systems to share the exact same memory format over a network connection. It is raw speed for transactional streaming.
So we have cosmic highway algorithms, zero-copy library cards, and mathematical noise dials.
We do.
But what happens when a business scales faster than its architecture? When the rubber eventually hits the road, things break, both technically and financially.
They absolutely do.
I was reading about Netflix in the sources. They had to build dynamic partition splitting in Cassandra at runtime. Explain the business impact of why that was necessary.
Well, Netflix deals heavily in time series workloads, specifically a user's viewing history. In a database like Cassandra, data is stored in buckets called partitions.
Okay, bucket.
If you rely on static buckets, a highly active user who binges shows all weekend will fill up their specific bucket so fast that it creates an oversized, wide partition.
And what happens then?
That single hotspot will literally crash that node of the database. Netflix had to engineer a system that detects these hot partitions while the database is running and automatically splits them in half without dropping a single frame of your movie.
That's insane engineering. Warner Music Group ran into a completely different wall, though.
Oh, the timescale DB issue.
Yeah. Imagine Warner Music trying to process global royalty data for millions of streams. They were using timescale DB, and they initially tried chunking that data into 30-day blocks. The system literally choked on its own side.
It was causing catastrophic compression failures. The sheer RAM and CPU required to compress and backfill a month's worth of global music streams at once just exceeded the physical limits of their servers.
So what did they do?
They were forced to shrink their data chunks down to 7 days just to keep the lights on and the pipelines flowing.
And then you have Gorgeous, the customer service platform. They tried to build a usage-based billing pipeline using Apache Flink. They hit a massive wall with their historical data. What exactly broke there?
It was an issue with event time guarantees. When Gorgias tried to reprocess historical data, they experienced overlapping windows.
What does that mean in practice?
Basically, internal repartitioning scrambled the chronological timeline of events. Imagine getting billed for a phone call before you even dialed the number.
Oh, that's a nightmare for billing.
Yeah. To fix it, they had to perfectly align their keys and apply conditional extra delays just during replays to force the system to respect the space-time continuum.
These are highly sophisticated engineering teams wrestling with the raw weight of their data. But the cost isn't just technical, it is heavily financial, and the community is starting to scream about it.
We're seeing a lot of pushback.
There was a massive Reddit backlash recently over a platform called Dagster. Their managed pricing jumped 10x practically overnight.
Yep.
It is pushing smaller users right back to self-hosting or forcing them to jump ship to competitors like Airflow or Prefect.
If we connect this to the bigger picture, this highlights a critical tension. Building fast for today versus building sustainably for an AI-driven tomorrow. Startups are suffering from what the sources call early DBT configuration debt.
Like taking shortcuts early on.
Exactly. They make simple mistakes early on to move fast, like forcing full project rebuilds for every minor code change or accidentally sharing development and production schemas.
And then the bill comes due.
Suddenly their cloud compute costs are astronomical and their basic data pipelines take hours to run.
Which brings us full circle to my opening thought, the Tableau exodus. Is the Tableau exodus just a knee-jerk reaction to cost, or is the actual value of a dashboard fundamentally changing for executives?
It is a fundamental shift in perceived value. The newsletters make it clear that executives are not cutting Tableau because a different dashboarding tool is technically superior.
Why are they cutting it then?
They are cutting it because traditional business intelligence feels dead in an AI-first world.
Wow. I guess, why pay massive licensing fees for a static dashboard of pre-computed charts when you can just ask an AI agent powered by a semantic ontology and a zero-copy architecture to analyze the raw data and give you the exact, specific answer you need right now?
Exactly that sentiment. The smart response from data teams isn't to fight tooth and nail to save the dashboard. It's to preserve the critical underlying metrics, migrate to cheaper consolidated platforms, and completely rethink how the business interacts with its intelligence.
What an incredible deep dive today. We started by unpacking Wes McKinney's push for agentic engineering, treating AI as the fast sous chef while humans remain the head chef.
A crucial shift in mindset.
We explored Amazon's realization that ground truth is a continuous, fluid debate between AI and human auditors. We watched the physical plumbing of the internet shift with Salesforce's 120 trillion row zero-copy architecture and the cosmic highways of vector databases.
The infrastructure is just completely transforming.
And finally, we saw the brutal realities of scaling. From Warner Music Group chirking on 30-day chunks to the Tableau exodus driven by the new AI-first mindset.
This really raises an important question for anyone listening. The raw capability of AI is no longer the limiting factor. The competitive advantage now belongs entirely to the teams who can mathematically govern their data, build resilient, zero-copy infrastructure, and maintain human judgment at the center of the loop.
So as you go back to your own data, your own spreadsheets, and your own teams, I want to leave you with a final thought to mull over. If ground truth is now a continuous process of AI challenging humans, and executives are dumping static BI dashboards like Tableau because they want dynamic answers, what happens to the boardroom of the future?
It's a wild thought.
Will the visual charts and graphs we rely on today be completely replaced by real-time audio debates between competing AI agents, each representing different company datasets, arguing out loud over the best path forward while the executives simply sit back, listen, and decide? Thank you for joining us on this deep dive. Keep questioning the data around you.
Spoken Tech for your ears.